For nearly a century, we slept soundly with a very specific picture of our cosmic home hanging in our heads. It was a tidy clockwork map. You had the sun, the 4 rocky worlds where we live, the 4 gas giants protecting us, and then at the very edge of the map, the lonely, icy outpost of Pluto. It was neat, it was complete, it was safe. But deep in the frozen dark, billions of kilometers past, where any map maker dared to draw a line, a ghost was lurking. It wasn't just a rock, it was a bomb waiting to go off. This object had been drifting across our astronomical photographs for years, totally unnoticed, hiding in plain sight. But when we finally saw it, it didn't just add a name to the list of planets. It destroyed the list entirely. It forced the smartest astronomers on Earth into a bitter, shouting match conflict over the definition of a single word. It turned the scientific community into a battlefield and rewrote the textbooks you grew up with. This is the story of the world that murdered Pluto. And if you think you know why Pluto was demoted, trust me, the reality is far stranger and far more chaotic than the headlines ever told you. To understand how this happened, we have to look at the man who pulled the trigger. His name is Mike Brown, an astronomer at Caltech. And frankly, he wasn't trying to destroy a planet. He was trying to find one. See, in the early 2000s, the outer solar system was the Wild West. We had found Pluto in 1930, but since then, the space beyond Neptune had remained largely blank. Brown and his team, Chad Trujillo and David Rabinowitz, were on a mission to fill in that blank space. They were using the Samuel Oschin telescope at the Palomar Observatory, running an automated dragnet of the night sky. They were hunting for trans-Neptunian objects, or TNOs, and they were finding them. They found Quar, they found Orcus, they found Sedna, but these were all just stepping stones. They were looking for the big one. As Brown later admitted, the idea that Pluto was the only big thing out there seemed absurd. There had to be a 10th planet. On January 5th, 2005, the breakthrough happened. Brown was manually rechecking data that his automated software had actually ignored. He was clicking through images taken years prior, in October 2003, and there it was, a faint point of light moving so slowly against the background stars that it could only mean one thing. It was incredibly far away. But here is where the expectation versus reality gap kicks in. You'd expect a distant object to be dim. This object was bright, unusually bright. In astronomy, if something is very far away, but still very bright, it means it's either made of mirrors or it is massive. Brown's immediate reaction wasn't, I found a TNO. It was, I found a planet. They nicknamed it Xena after the warrior princess because they knew this thing was going to fight its way into the history books. But they wanted to keep it secret, just for a little while to confirm the data. But in the cutthroat world of astronomy, secrets don't last. Another team in Spain announced a different discovery, Haumea, using data that looked suspiciously like it came from Brown's observation logs. Fearing they were about to be scooped on their biggest find, Brown's team had to rush. On July 29, 2005, they dropped the bomb. They announced the discovery of an object that was, according to their data, bigger than Pluto. And that is when the trouble started. This wasn't just a scientific discovery, it was a logical paradox. If Pluto is a planet and this new thing is bigger than Pluto, then this new thing must also be a planet. That gives us 10 planets. But if we let this one in, what about the next one? And the next one? We were staring down the barrel of a solar system with 15, 20, maybe 50 planets. The word planet was about to become meaningless. The alternative was even worse. If this new object wasn't a planet, then Pluto, which was smaller, couldn't be a planet either. We had to either add a chair to the table or kick Grandpa out of the dining room. There was no middle ground. This object was eventually named Eris, and the name could not have been more perfect. In Greek mythology, Eris is the goddess of strife and discord. She's the one who starts wars just for the fun of it. And true to her name, this little ball of ice and rock dragged the International Astronomical Union, the IAU, into a civil war. In August 2006, astronomers gathered in Prague for what became the most controversial showdown in the history of the field. The goal was to finally define what a planet actually is. It sounds simple, right? It wasn't. The room was split into 2 hostile camps. On one side, you had the geophysical crowd. Their argument was romantic and physical. If a world is big enough that its own gravity pulls it into a round shape, it's a planet. Simple, elegant. Under this rule, Eris is a planet. Pluto is a planet. Even the asteroid Ceres is a planet. The solar system becomes a crowded, bustling place. On the other side, you had the dynamical crowd. They didn't care about what the object looked like. They cared about what it did. They argued that a real planet is a bully. A real planet dominates its turf. It must be the gravitational boss of its orbit. The debate raged for 10 days. It was messy. But the vote itself, that was the real twist. The final vote took place on the very last day of the conference. By that point, most of the 2,500 astronomers had already packed their bags and flown home. Only 424 people were left in the room. Think about that. The fate of the solar system, the textbooks of billions of children, was decided by 424 people in a half-empty hall in Prague. The dynamical camp won. They passed Resolution 5A. To be a planet, you had to do 3 things. Orbit the sun, be round, clear your neighborhood. That third rule was the sniper shot aimed directly at Pluto. Pluto shares its orbit with thousands of other debris objects in the Kuiper belt. It hasn't cleared anything. It's just one fish in a very big school. Eris, living in the even wilder, scattered disk, hadn't cleared its neighborhood either. In the blink of an eye, the solar system shrank from 9 planets to 8. Eris, Pluto, and Ceres were shoved into a new second-class category, dwarf planets. It was a PR nightmare. People were furious. But scientifically, it was the moment we finally grew up and accepted the solar system for what it actually is, not what we wanted it to be. But here is where the story gets really interesting. Because while we were all arguing about labels, we were ignoring the world itself. And Eris is weird. If you were to stand on the surface of Eris, you wouldn't be standing on a simple ice ball. You'd be standing on a world that breathes. Eris follows a chaotic elliptical path. It takes 557 Earth years to go around the sun once. Its orbit is wildly tilted, sending it soaring high above the plane of the other planets and then diving far below. At its closest, it rushes in as near as Pluto, but at its farthest, it swings out to nearly 100 astronomical units, 3 times further than Pluto. This extreme orbit creates a planetary heartbeat unlike anything else. When Eris is far out in the deep freeze, its atmosphere literally collapses. The nitrogen and methane gas freeze solid and fall out of the sky as snow. But this isn't a light dusting. The entire atmosphere turns into a bright, reflective glaze on the surface. This is why Eris was so hard to identify at first. It has an albedo of 0.9. It reflects 99% of the sunlight that hits it. It is whiter than fresh fallen snow on Earth. It is blindingly bright. Then as it swings back toward the sun, a journey of nearly 300 years, that frozen atmosphere warms up, sublimates, and turns back into gas, wrapping the world in a thin sky once again. It's a cycle of death and rebirth that plays out over centuries. But the biggest surprise came when we tried to weigh it. For a long time we thought Eris was just a bigger Pluto. But in 2010, Eris passed in front of a star, and we got to measure its size with perfect accuracy. The result was a shock. Eris is almost exactly the same size as Pluto. In fact, it might be a tiny bit smaller. Wait, hold on. If it's smaller, why did we think it was bigger? And why did it cause such a panic? Because size and mass are not the same thing. Eris is smaller than Pluto, but it is 27% more massive. Let that sink in. It is significantly heavier than Pluto packed into a smaller space. This tells us something profound about its interior. Pluto is a fluffy mix of rock and ice, about 70-30, but Eris is a rock. It's a dense, heavy, metallic world with just a thin shell of ice on top. It's the heavy metal version of Pluto. And how do we know the mass so precisely? Because Eris isn't alone. In September 2005, using the Keck telescope in Hawaii, Mike Brown's team spotted a moon. And keeping with the theme of mythological strife, they named it Dysnomia, the daughter of Eris and the spirit of lawlessness. Dysnomia is the key to the whole puzzle. You can't weigh a planet by looking at it, but if it has a moon, you can watch how fast the moon spins around it. Gravity doesn't lie. Dysnomia's 16-day orbit proved that Eris was a gravitational heavyweight, but Dysnomia is also a mystery. Eris is blindingly white. Dysnomia is darker than coal. It looks like a piece of charcoal orbiting a diamond. The leading theory is that Dysnomia was born from a violent collision, a cosmic car crash billions of years ago that blasted debris into orbit, stripping away the volatile ices and leaving behind this dark, rocky little moon. So where does this leave us? Mike Brown is often called the Pluto killer. He even wrote a book with that title. But I think that's the wrong way to Look at it. He didn't kill Pluto, he liberated it. Before Eris, Pluto was the oddball. It was the misfit at the dinner table that didn't quite belong with the gas giants or the terrestrials. It was a lonely anomaly. But thanks to Eris, we now know that Pluto isn't a lonely mistake. It's a king. Eris and Pluto are the rulers of a vast third zone of the solar system. We have the rocky inner zone, the gas giant middle zone, and now the icy outer zone. This is a region populated by thousands of worlds. Sedna, Haumea, Makemake, Quaoar. These aren't failed planets. They are a completely different class of world that we are only just beginning to understand. Eris forced us to redraw the map. It forced us to accept that the universe is not tidy. It is not organized for our convenience. It is messy, it is complex, and it is full of ghosts. And here's the thing that keeps me up at night. Eris is currently 14 billion kilometers away. It is the most massive object in the solar system that we have never visited. We have seen Pluto up close with the New Horizons probe, and it was beautiful. Complex geology, mountains, glaciers. If Eris is denser, rockier, and has an atmosphere that collapses and reforms, what does its surface look like? What kind of ice volcanoes or geothermal scars are hiding under that blinding white snow? We don't know, and we won't know for a long time. A mission to Eris would take 25 years just to get there. It is a generational journey. But the discovery of Eris teaches us one final lesson. For 70 years, we thought we saw everything. We thought the map was done. Eris proved that even in our own backyard, there are monsters hiding in the dark. And if a world as massive as Eris could hide from us until 2005, what else is out there? Mathematical models suggest that there might be something else, perturbing the orbits of these distant objects. Something much, much bigger than Eris. Something bigger than Earth. Eris might have killed Pluto. But it also opened the door to the possibility of a true Planet 9, a super Earth lurking even further out, waiting for its own ghost story to be told. But that is a mystery for another time.